So we have a quadrilateral, it's actually a trapezoid, bounded by the x-axis, the y-axis, the line y equals 6, that's this guy, and the line y equals ax plus 8. What's the area of the region? There's two different ways you could think about it. You could think of it as the trapezoid, and the area for that is 1/2 base 1 plus base 2 times the height. So we would need to know the two bases and the height. We know the height is 6 because y equals 6, so that's 6. Alternately, you could kind of divide it up into a triangle and a rectangle and then solve for those two areas and add them together. Either one is cool. We still need to know these respective distances because we need the base of the triangle and the base of the rectangle, or the two bases for the trapezoid. Statement 1 tells us that the point 1, 6 is on the boundary of the quadrilateral. And which sounds, I guess, sort of helpful. It tells us that there's a point somewhere along this line up here, but it could be in the middle, or it could be right at this intersection. We don't actually know whether it's on the line y equals ax plus 8, or just somewhere in the middle here. Without knowing that, we can't figure out whether it represents the boundary of that upper base and is therefore insufficient. Also, we don't have the bottom anyway. So no good on its own. Answer choice D can't help us. Statement 2 tells us that the point 6, 5 is on the boundary of the quadrilateral. I'll do this in green. So 6, 5, since it has a height of 5, it can't be on this line y equals 6. And so it means it's somewhere on this line, which, you know, is trouble, I guess, because it doesn't give us any of the bases or anything like that. However, it does give us two coordinates, and from there we can actually figure out the equation of the line. If we do that, so you know, we have y equals ax plus 8. We plug in our two values, so 5 equals 6x plus 8. We end up with a equals -1/2. Therefore, the equation of the line equals y equals -1/2 x plus 8. From there, all we have to do is plug in values for y equals 0 to get this point. And then when we get what the x value is, we have this distance. And for this one, we would plug in y equals 6 because it intersects with the y equals 6 line. And whatever the x value is for that, that's the length of this base. We can either do the rectangle and the triangle or the trapezoid, whichever formula you prefer. So statement 2 is indirectly and complicatedly sufficient. Answer choice B.